So 5 cards are randomly chosen from a standard deck, one at a time with replacements, and X and Y and Z are random variables that X counts the number of queens, Y number of kings, and Z number of other cards. We have to find the joint PMF of these random variables. So let's start by writing out the PMF of X, Y, and Z. So how should we think about this? We are not given the, right, explicitly at least, the distribution of X, Y, Z. But if we think about it, what does it mean that we are, what X, Y, and Z actually imply? Well, X, Y, and Z are jointly multinomial with 3 categories. Just going to write multi-n with we selecting 5, and we have a vector of probabilities. I'm going to write it like so, and that means, so what does it mean to select? So what's the probability of selecting a queen? Well, the selection for queens is, we have 4 queens and 52 because of replacement. Same with kings, 4, 52. And the number of other cards, and that's 52 divided by 44. So if we're going to simplify these numbers, we have 113, 113, 1113. Okay. And these are now independent draws with replacement, so we can start writing them out as the number of x's and that those have those probabilities. So if we select 1, we are selecting 113. Otherwise 2, we multiply at 113 2 times. And the same with y, and the same with let's write simplified one, 1113 z. And now we're saying that order doesn't matter. So we have 5 positions in our hand, 5 of them, and we're selecting a card, we're selecting another one, but order between them doesn't matter. So we have, how many ways can we select 5 cards? Well, that's 5 factorial. But because order doesn't matter between the x terms, so the queens, we have to remove those. And the same with the y's, and the same with the z's. And so this is the PMF of the joint PMF of x, y, z. And we can also write, just for sake of reminder, that x, y plus z has to equal 5. Okay, so moving on to the other question in B, here we asked to find the joint PMF of x and y. And we're also given a hint. So when we sum over the joints, we can note that most of the terms in Z are 0 because of this constraint, which is good. Otherwise, we will have a lot of terms to deal with. So x, probability of x, or the PMF of xy, is we get that by summing over the joint of x, y, z, like so. Okay, and now we simply write out factorize p of x, y conditioning on z, because that is what we want to sum over. So it's natural to condition on x and on z. And now what is z? Well, z has to be such that it respects, z has to respect this constraint that we are given, that x, y plus z, they have to be summing to 5. Okay. And moving further here, we can now write out the PMF just as it's given. So we are now basically subtracting off all the other remaining variables. It's basically multinomial category 2 with 2 categories. So how do we think about that? Well, we can think about it in the same way as we thought about the first question, but now basically treating z as not relevant variables, but we still have to account for them, obviously. So we have to select the z's, the x. Let's start with the x's. So now we have 113 x's, we have 113 y's, right? Those are the sort of the success categories, and we have to now select the other set of variables, but we have now summed over z, so this will be 5 minus x minus y. And we get that by basically setting z equal to 5 and subtracting off x and y. And here, same thing, we have to subtract off order because order doesn't matter. X, y, and then we have to remove off x and y. Okay, so it became a little short on space. Let's remove this like that. Y and factorial. Okay, so this answer now, so x and y have to operate, and so this is the new constraint. X and y have to operate up to 5. So it could be that we select 0 other cards. That's totally fine here. And so what happens, and just looking at the difference here between the joints where z is written and the joint of all 3 and the joint of x and y, they look pretty similar. It's just that here we're explicitly selecting z's of interest, and hence we have this term here. Here we're saying, oh, so these are the success categories and these are the none, so this is just bunched together, and now we're replacing z with this new term here. Okay. Now we're asked to sample without replacement. So all 5 cards are obviously equally likely. We're asked to find the joint. The hint here is to rely on the naive definition of probability. Okay, so C here, and now it's without replacement, x, y, z. So what does this problem remind us of? Well, it reminds us of the hypergeometric and sort of the ELK problem. If you read the first chapters of the introduction to probability, and here we can then think about this in different ways. One way is just using hypergeometric, and another way is to think about just the meaning of selection. So basically, first principles here. Okay, so let's do the hypergeometric, and then I'm going to think about this problem in terms of first principles. So the hypergeometric says that we can select from the 4 available queens X, and then we can multiply them together because they're independent. 4, and the same with the kings, and the same with the other categories. So we have 44 of those, selecting Z. And then because all of them are equally likely, and we have 52 cards, so and we select 5, sorry, it should be 5 here. We can divide them by 5. So these are basically all the possible combinations of selecting a 5-card hand, and these are the ones that fulfill the PMF restrictions or conditions. And here again, x plus y equal x plus y plus z equal 5. Okay.